AI system for an AI system for predictive maintenance in commercial refrigeration systems. A few words about the company. The company is an engineering and consultancy and construction company founded in Thessaloniki, Greece. It's operating since 1984. It started with air conditioning installations, but by now it's covering all the HVAC systems and has a very global coverage of the energy domain. Right now, we are just below 50 people, where most of them are engineers and technicians, but there are also some administrative and financial personnel. There is a very huge expertise since the company is quite old concerning the area here, Greece. We provide state-of-the-art integrated solutions for property owners, investors, engineering consultants, contractors, and of course traders of HVAC industry, both in Greece and abroad, in Germany, Belgium, and some other countries. And the major asset of the company is the development of custom HVAC installation systems for highly complex and fragile environments, such as wineries, food storage and processing facilities, and surgery rooms, which all of them require delicate equilibrium of conditions. Now, I will go through this very fast. The company, as I said, it's been operating now for almost 38 years. It has 10,000 projects on its back. It's about 350 to 400 projects per year. And there are a lot of units installed, and there are a lot of pilots and many projects like tourist resorts, as I said, wineries, manufacturing plants, and much more. Now, what is the idea that Klimamechanik wants to implement? There are, of course, commercial and industrial refrigeration applications all over the world. And the main issue they have is that there are some malfunctions that, even if they are rare at the moment, they are extremely costly, mostly in time, because there is a lot of downtime and it takes time for ordering parts, especially after COVID, and repairing the damages. And of course, the economic cost, which is about how much the replacement parts cost, and the damage produce, which is the most important part, especially when we talk about high value products. So the solution would be to apply artificial intelligence to develop a model that can perform malfunction prognosis. So this means that it will predict when the system will break. So the implementation is to install some sensors in a pilot where there are refrigeration condensing units installed, collect the data and save them in data storage, develop the AI model, and then eventually create a platform where it will be provided as a subscription service to the clients and to the customers. So the pilot, the system setup we have a system that it comprises of 5 internal units at a location here also in Thessaloniki, Greece, and 5 external units. And each of these units is equipped with multiple sensors for temperature and humidity and consumption, and a lot of flags about when it operates, what kind of operation it performs, the fan speed, and so on. The system at the moment is installed in an application where they use some Daikin compressors and some Gunter systems that they are cooling storage with some high-value cheese. For sensor setup, we have an Arctic system. It's called like this. It provides data logging and storing into a cloud service, and it also provides some web interface with alerts so that we know if a system has broken down. Now, by the data we have collected, we have created a very simple forecasting model where we have aggregated the daily mean of all the energy consumption we have through the day. And we have created a 7-day ahead forecast with an ARIMA model. As we see, the forecast, which is here in orange, is very close to the green plot, which is the real, the actual energy consumption. And even though it's not exactly matching, we have a very good trend of the energy consumption in the following working week. This is quite important to identify any changes in the energy consumption while we want to predict some malfunctions. Now, the anomaly detection, which is another part, again, conducted with artificial intelligence and some algorithms. It's performed so that we know if something goes out of the ordinary based on other variables such as temperatures and more. So since we have a lot of variables, we decompose these variables and then we plot them in a 3D environment, and then we apply DBScan, which is an AI algorithm, to identify some anomaly points that occur during the operation of the machines. We see that in general, we have only a few anomaly points. However, we see this, which is on another case, on another machine, one out of the 5. We see that this machine operates in 2 different normal conditions. However, it provides some outliers, which means that there are some cases that cannot be identified with one of these 2 conditions. Again, these results are quite preliminary, and these things have to go through our HVAC engineers in order to identify what is really going on. So from EOSC, we actually want, and we want to use their services about OpenAir Explorer to identify what's going on in the competition, let's say, or in the literature. The AGI notebook, where we want to train our models. The deep training facility, where we will train our models, of course. The Argo service for our data management plan, and B2Share to disseminate this information and create maybe some networking so that we take this project and upscale it. So the activities that we want to be engaged is to research the literature for the state-of-the-art models relevant to the pilot, to develop and validate the AI models that we have developed. And of course, in the end, to disseminate our actions and results and create a network that will allow us to even further engage in such activities. And what PreMaCOOL aims to achieve is to take some traditional solutions that are used at the moment, identify some market-driven HVAC domain problems, apply AI and IT to these problems, and create custom modeling and software solutions that it will use not only to use on its own, but to create to bring ahead of the competition the company. That's all from me. Thank you very much.